In this presentation, our perspective is to discuss introduction of physics of semiconductor. Most of the modern electronic devices are made of semiconductor. Semiconductor are materials which have electrical conductivities lying between those of good conductors and insulators. There are elemental semiconductors such as germanium and silicon. Let's see the electronic configuration of germanium and silicon. The atomic number of germanium Z is equal to 32. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2, and atomic number of silicon Z is equal to 40. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. Above electronic configuration, we can say germanium and silicon both belong to the group 4 of the periodic table. Atoms of both germanium and silicon have 4 valence electrons. That is, germanium and silicon both are tetravalent. Apart from germanium and silicon, there are compounds like gallium arsenide, indium phosphide, indium arsenide, etc., which show semiconducting properties of semiconductor. These are called compound semiconductor. Right now we are not getting into compound semiconductor. Let's see band gaps of silicon and germanium. The band gap between conductor bands and valence band of a germanium almost equal to 0.7 electron volt, and for silicon the band gap between conductor bands and valence band almost equal to 1.1 electron volt. All semiconductors behave like a perfect insulator at absolute zero temperature. As a semiconductor device material, silicon is superior to germanium because germanium is highly temperature sensitive as compared to silicon. Germanium and silicon, they have diamond lattice structure. Thank you for watching this lecture. See you in next presentation.